Okay, in this next lesson, which we will do via a lesson video, we are going to talk about angles. Some of this material, defining, naming, classifying angles, some of this should be review for you for middle school, and then we'll talk about some things like the angle addition postulate, which will seem similar to the segment addition postulate. First of all, let's go ahead and define what an angle is. In geometry, we define an angle to be two different rays with the same initial point. So we have defined what a ray is. So here's the initial point of 1. Let's draw our ray. Let's say that this is ray DE. And then from that same initial point, we have another ray. Let's call that DF. So we have this angle. Again, it's two rays, ray DE and ray DF. They share that same initial point. We will get into now how to actually name an angle, and there are several different ways to name an angle. We need to be careful that we're always putting the vertex, which is that initial point. So in the first example, it would be D, would be the vertex. The vertex needs to be in the middle. Vertex needs to be in the middle when we are naming angles. So if we look at this first example over on the left, first of all, I want you to highlight your vertex. Highlight your vertex, which in this case, the vertex is point Y. So when we name this angle, we need to make sure that that letter is in the middle. We can name this angle as angle FYS. We can also name this angle as angle SYF, so we can go the other way, keeping in mind that that vertex is in the middle. Or we can also name this angle as just angle Y, using just the vertex. When we say angle Y, in the picture, that is the only angle, that is the only one I could be referring to. If you look at the other picture, on the other hand, we have a couple different angles within one picture. So what I first want to do is, again, have you highlight the vertex. In this case, it's Q. We have several different angles. We have this smaller angle we can name as angle PQS or angle SQP, either way. We can name the other smaller angle right here as angle SQR or angle RQS. Again, we're keeping the vertex in the middle. Now, there's actually another angle in this picture. Do you know where it is? Well, we have the biggest angle in this picture, that one. So we can name that big one angle PQR or angle RQP. Now, here's what we cannot do in this example. We cannot say or name any of these angle Q. We cannot name any of those angle Q. Here's the reason for that. If you just say angle Q and you're using this picture, well, I have no idea which of those three angles you're referring to. In the other picture, there was only one. That was the only one I could be referring to. But here, because there's 1, 2, 3 angles in that picture, I cannot just use that vertex letter. I have to be more specific. All right, we are going to look at now the angle addition postulate. Again, this is going to be very, very, very similar to our segment addition postulate that we looked at a couple classes ago. Basically, this is the part plus the part equals the whole. So the measure of this angle plus the measure of this angle has to equal the measure of the whole thing. We are going to use our letters to name these angles. The measure of angle PQS plus the measure of angle SQR equals the measure of the big one, PQR. Okay, again, that's very similar to your segment addition postulate. All right, let's turn our attention to classifying angles. This is probably going to be familiar to you. It's something that you've done several times in your math career. We do have different types of angles. The first one that we'll talk about is an acute angle. So this is an angle whose measure is between 0 and 90 degrees. We have an obtuse angle. That's an angle whose measure is between 90 and 180 degrees. We have a right angle. A right angle has a measure of exactly 90 degrees. That always looks like a corner, denoted by that little square box. And then finally we have, this is maybe something you're not too familiar with, we have what we call a straight angle. A straight angle has a measure of 180 degrees. What it's going to look like to you is a line. So just kind of keep in mind that a line has a measure of 180 degrees. We can also call that a straight angle. All right, let's talk about adjacent angles. These are angles who share a common vertex and a common side. So let's start with our common vertex. Here's one angle. And then from that common vertex, we're going to share the middle side and draw another one. So there are two angles in that picture. They're sharing, again, this vertex right here and that side. For what we call an angle bisector is a ray that bisects. We should know what that word means. It means cuts in half. Cuts in half an angle into two congruent angles. We've talked about segment bisectors. Now let's talk about an angle bisector. So here's my angle. Let's call this EFG. If I have a ray, let's say ray FH, and if that ray cuts my original angle EFG into two congruent angles, then that is an angle bisector. All right, we have our first example here. It says to name the vertex and the sides of each angle. I'll do the first two with you, but then I'll have you stop the video and do the last two on your own. So I'm first looking at angle 5. So angle 5 is right here. The vertex, remember the vertex is a point. The vertex of that angle is point M. Remember, we name points with just a capital letter. The sides of that angle, we're going to think about that angle extending. One side is ray MN. The other side is ray MO. Remember, angles are made of two rays from the vertex point out to the other point. The next example, we're looking at angle 3. So that's right here. The vertex is point P. The sides are rays PR and ray PQ. Now what I want you to do is pause this video and I want you to do those last two examples on your own. Pause the video and do those last two examples on your own. All right, check your answers. That is the vertex and the sides of the two angles that you should have done on your own. All right, what we have is just a few more examples. Number 2 is using the angle addition postulate, and there is one typo that you are going to have to change in the information. This first angle should be angle POQ. Okay, so in the instructions it says to let Q be in the interior of angle POR. So I'll draw angle POR. And when it says let Q be in the interior, that means Q is on a ray somewhere inside that angle. So that's what your picture should look like for this information. All right, use the angle addition postulate to solve for x, then we're going to find the measures of the angles. So let's use this information, fill in our picture. We're told the measure of angle POQ is x plus 4. We're told the measure of angle QOR is 2x minus 2. And then we're told that the measure of POR, so that's the whole thing, is 26 degrees. Well, our angle addition postulate says the part plus the part has to equal the whole. So we're going to do just that. So the first part plus the second part equals the whole thing. And then from there, it's just an algebra problem. Combine your like terms and solve for x. We now need to find the measures of the angles. So we can take our value of x and plug that back into the expression. So if I plug 8 in for x, 8 plus 4 is 12. So the measure of angle POQ is 12 degrees. If I plug 8 into x here, that would be 2 times 8 is 16 minus 2. So the measure of angle QOR is 14 degrees. Notice that the whole thing was 26, so 12 plus 14, that's 26, so that must be right. All right, next example. We are told that ray BT bisects angle ABC. You have to know your vocabulary. When you see that word bisects, you should think cuts in half. If angle ABC is cut in half, that means the two parts are congruent. If the two parts are congruent, that means their measures are equal. If the parts are congruent, then the measures are equal. So to first find the value of x, we'll set those expressions equal and solve just an algebra problem from here. So the value of x is 5. Now we need to find the measure of angle CBT. The measure of angle CBT, its expression is 5x plus 28. And now I can plug in the value of x, which is 5. So the measure of angle CBT should be 53 degrees. Okie dokie, last example, here we go. It says in the figure, CB and CD are opposite rays. So we know that this is a straight line 180 degrees. Let's see. CE bisects angle DCF. So this ray bisects this angle. That means these two are congruent. We're told that CG bisects FCB. So that means these two are congruent. I'm recording a video. Can I come back? It's okay. It's okay. Okay, so let's fill in our information. We're told that the measure of angle DCE is 4x plus 15. Well, here's what we know. Let me zoom in. If I know that this angle and this angle are congruent, and I know that measure, that means that this one also has to be 4x plus 15. We're also told in the problem that the measure of angle ECF is 6x minus 5. So we're given more information. We actually now have two expressions for the same angle. So what we can do with that is we can set those two expressions for the same angle equal to each other. These two expressions are both representing the measure of that angle, so they have to be the same. From here, again, just an algebra problem. The value of x equals 10, but what we were asked to find is the measure of angle DCE. So DCE is 4x plus 15. So let's just plug in that value of x. Make sure you're using degree symbols when you need them.